This session is on StringBuilder and StringBuffer classes. So there's an interface called character sequence, which represents the sequence of characters, and StringBuffer and StringBuilder. These classes is implementing this interface. So basically, they are the classes used to create the strings. In this, string is a immutable class, as we know. StringBuffer and StringBuilder is going to be mutable classes. So they produce basically mutable strings. StringBuilder, StringBuffer, both classes provide same methods to users. Functionally, they are one and the same. But StringBuilder is more preferred than StringBuffer. So most of the times we'll be using only StringBuilder and not the StringBuffer. Only when there is a thread safe requirements coming into picture, we may consider using the StringBuffer. StringBuilder is not thread safe, and the method in this class can be invoked by multiple threads simultaneously, but it provides more performance. Whereas StringBuffer is a thread safe, but the methods in this class cannot be invoked by multiple threads simultaneously, and because of this, it provides less performance, and all the methods in the StringBuffer are synchronized. So we'll talk about what is multiple threads entering simultaneously, or what is synchronization, all these things in the thread sessions. If you want to understand now what it means, basically is you can think about an account object. You have a kind of a joint account actually. Both husband and wife are accessing that account in a joint way. Assume there is a 5,000 balance in the account, and both husband and wife, they go to the bank, different ATMs simultaneously, and they put their ATM card, and that they try to access, they try to retrieve $5,000 each. The total account is having only 5,000, but they try to attempt to take $5,000 from the ATM. In a multi-threaded scenario, what happens is you can consider husband as one thread and wife as another thread. So they try to access $5,000. They enter into this account object simultaneously, and they perform the debit of 5,000 simultaneously. Okay, so they both enter into the withdraw method. They try to get the they try to withdraw the $5,000 there. So the withdraw method may have a check for comparing the balance, but what will happen is the balance, when it is comparing the balance, it was having 5,000 for when they enter into the withdraw method, they will see that balance is 5,000 for both of them. So it basically allows they have sufficient balance, and it allows to withdraw. So this is a case where multiple threads accessing getting into the same method, withdraw method, simultaneously. Okay, in this situation, this should not be allowed. So this method should have been in a synchronized way. This should be accessed in a synchronized way, which means it should allow only one thread at a time. If husband enters the thread, then we have to make the wife thread to wait till husband completes the transaction, so that when wife enters, she will see that it is $0. So she cannot take she cannot make her account as a negative balance account. So this is the things we are trying to prevent by using the thread safety, which we'll discuss more in the thread sessions. But as of now, you can understand the StringBuffer is kind of implementing such that only one thread can enter at a time. But StringBuilder allows both the threads to enter into and perform updates onto the object. So if you are having one StringBuilder instance, and if you are sharing that instance between multiple threads, the multiple threads, if it is a read only, we don't have a problem, but if multiple threads are updating the same object, you will get some inconsistent results when you use StringBuilder. So only in that scenario, StringBuilder is not to be used. Other than that, if you don't have that requirements, you have to use StringBuilder. That's a preferred way of going forward. Mutable strings. So this is the way basically to create a StringBuilder, just like any other objects, like a person p is equal to new person of. Here we have a constructor also, which can be used to pass a string there when you create a StringBuilder object. So the StringBuffer is done in the similar way. So in the heap memory, if you see how the allocations is made, we'll create a ABC in the heap memory, not in the string literal pool or anything. So it's just created in the heap memory, just like any other objects. and you have SB1 will be pointing to that memory location. SB2 will not point to the same memory location, as you know, because it's a new operation. Of course, it is going to get created in the new memory location. So SB1 will be 5000, SB2 will be 5200, like this, even though they store the same content actually. It's unlike strings, so the string buffer is also going to do the same thing. There is no other way to create a string buffer. Like, you cannot say string buffer SB1 is equal to ABC. You have to do always with the new operator. Unlike strings, they don't have another syntax for creating it. It's just like a regular object. So coming to the mutability part of it, like if you see like SB1 equal to SB2 here, of course it's going to be false. When you do SB1 dot append of XYZ, in string scenario, what will happen is XYZ will be created as a new string literal, and then you will have ABC XYZ as another string literal, and you'll be making your reference to point to that ABC XYZ address. That's how string works. But in case of string buffer, it does not do all those things. It just updates the existing memory location. It replaces the ABC with XYZ. So here you don't need to assign it back to SB1, just like how we do it in the string, because it's going to update the same memory location only, just like any other object. Like if you're going to person.name is equal to, if you're changing that, it's going to update the same memory location. The same way it works. So then we'll go with the equals method. In strings, we have like string S1 is equal to ABC, string S2 is equal to new string of ABC. Even though they are two different memory location, if you put S1 equal to S2, they are going to be coming as false. But when you do S1 dot equals, it is going to compare the contents. When it is comparing the contents, it's going to be true here. Let's see what will happen for string builder. If you do the same thing with string builder, it is expected to compare the contents, but what will happen is it is going to return false. Why that is the case? Why it is returning false? Because equals method is available in string builder, but still it's, we are able to invoke equals method with string builder, but still it is giving us false. That is because the equals method is an overridden method. Equals method is present in the object class. String basically tries to override the equals method, and it provides its own implementation. But string buffer did not override the implementation of equals method. So which means it is going to use the object class equals method. So when you are trying to invoke, any class is going to extend from the object class, which means string is also extending from object, string builder is also going to extend from object. In this scenario, what is going to happen is there is an equals method in the object class which compares the references. So it is going to just check SB1 equal to SB2, which is going to compare the references. In this case, SB1 equal to SB2 is false because they two are pointing to two different objects. What the equals method is going to do is the same as the double equal to operation, as you see here. But why in string alone it works is because string has overridden that equals method in its class, and it has provides its own implementation there. That is the reason string was able to compare the contents. If string buffer would have overridden that equals method and provide the implementation, we could have not had this problem. We would have still had SB1 dot equals SB2 would be true, but string buffer unfortunately did not override the equals method. Since it did not override the equals method, you are going to get SB1 dot equals as false, because it is going to use the objects equals method. Objects equals method is just doing the reference comparison. So these are the methods that is present in string buffer and string builder. You see they are same methods, one and the same methods. As I said, string buffer will have synchronized keyword before it, which means only one thread can enter at any point of time. Whereas in string builder, you don't have that synchronized, which means multiple threads can invoke these methods simultaneously, can enter into this method simultaneously. So as such, you see there are some methods like length. Length is basically just to see how much length it is, just like a string methods. Capacity is how much capacity you are having. And then append method, you can use append with any types, like you can use append of integer, append of float, append of double, append of character, append of string buffer. So you can use lot of arguments, a lot type of arguments with append method. Append is just like a concatenation. Concat method of string. And delete method, you can specify in a string buffer, you can start with the character and you can delete that. You can specify, begin and the end, from which character to which character you need to, from which position to which position you need to delete, you can do that. Same is the case with insert. You can insert a string from a given position, actually in the third position, just in the third position. You can if you want to if you put 3 comma a string, it is going to insert that string in the third position of the given string. So replace method, as it's going to replace the replace it with the given string, actually. We have substring method, which is going to be the same thing what we learned in string. We have the index method, last index method, and we have a reverse method, which is going to reverse a string, which is a utility method present in the StringBuffer class. Let's see some examples with Eclipse. So let's go to this, create a class. Okay, let's talk the same example, like string s1 equals abc. Let's say string s2 equals abc. Let me make it as string s2 is equal to new string of abc, so that they always s1 equal to s2 will be false. Okay. So sys out s1 equal to s2. So this is a reference comparison, which is going to always get me false here. Let's do equals comparison, which is going to result in true. So false and true here. So let's do the same thing with StringBuffer and see what happens. StringBuffer or StringBuilder, and make it StringBuilder. So we cannot do like this, as we said. We cannot assign like a string for StringBuffer or StringBuilder. You have to do a new string builder. Okay, so the same thing with the SB2 as well. And I'm going to change this to SB1, SB2. So you see here, earlier it is true for s1 dot equals s2, but it's getting false for sb1 dot equals sb2. Even though the contents are same, it's giving me false. That's because the equals method has been overridden in string. Let me show you what happens here. If you click on this, you go to implementation of this equals method. It is going to the objects equals method, because StringBuilder as such does not have the equals method implementation. Since it is extending from object class, it's going to use the parent class implementation, which is just checking whether the current object is equal to the passed object with the reference comparison, which is nothing but invoking sb1 equal to sb2. Whereas in string, if you open the implementation, it is going to give you, they have overridden this object implementation. So you see string is checking each characters, and they are checking whether they are equal or not, actually. So string has basically overridden this equals implementation from object. Okay, so let's see one more example, like how so if at all you wanted to do this, if you want to compare the contents of this two, what you can do is you can always go ahead with the toString method. So toString is going to be providing you the string, basically convert the toString method is basically to convert any object into it's going to give its string representation basically. So again, this toString method is coming from the object class. If you go to the object class toString method, it's going to give you a sample implementation here in object class. Let me open both. So okay, I'm sorry. Let me show you the toString implementation here. This is the object class. Oh, I'm sorry. What I'm doing here. Take this out. So this goes to object class basically, as you see here, object.class. You see there is a toString method here, and object class toString method is going to give you the class name at integer.hashcode like this. So it's going to basically print out the class name and add symbol and some hash code which we will learn. It's just going to be giving some numbers actually out there. Now if you see SB1, let me do one more thing first. I can simply say string s3 equals sb1 dot toString of. So basically I can convert a string builder object into a string actually by using the toString method. What this toString method is going to give is, it's coming from the object class, but StringBuffer or StringBuilder has overridden this toString method. They have overridden this toString method. If you go and see this toString method implementation, they have done in StringBuilder class, they have overridden this toString method. So they have created a new string value from the StringBuffer object. So that is the reason you are able to, they basically get this value as a string and store it. I mean, they will be able to returning a string object here. Now when you have a string object, it is easy to use the equals method to compare the contents, right? So if at all you wanted to compare the contents of StringBuffer, all that thing you have to do is you have to convert that into a string, and then you can invoke the equals method on the string actually, which is indirectly making the conversion possible. Okay, so I'm just going to run this. So now it's going to return true because we converted into toString here. Okay, let's take one more example to understand how and in a regular object how this toString or equals plays a role, or how that works basically. New class. Let's take an employee class, and this employee class is okay. I'll write the main method later. This employee class is going to have say private string ID. Is going to have what else? Name, address. Okay. Now let's do a source and then say generate getter setters for this. So I would like to have all the getters and setters for this. Say let's generate. I'll have a convenient one for constructor as well. So let me go ahead and create one constructor using all these fields. Also, I want to create a constructor with no fields just in case. Yeah. So I have the constructors, I have the getter setter methods created for me. Now I have the employee class ready. Now what I have to do is I'm going to go with the employee test class to test this employee. Okay, let's run this, create a new class. And this will be employee test and having a main method. So here I'm going to create two employees. Employee E1 is equals new employee of. I'm going to use the overloaded constructor. So it's going to have like employee ID 100, employee name, let's say John, and what else? The parameter is address. Okay. address I will keep it as Texas. Okay, I'll create another employee which is going to be (101) James. Okay, so now we have two employees here. One is employee E1 and we'll create one more as E2. Now you all know, like if I do if E1 equal to E2, if I do a sys out for E1 whether employee 1 is equal to employee 2, of course I'm going to get false because they two are different employees. They have different references. They will be created two objects in heap memory. They point to different memory locations. They will not be equal. So this will be false. Okay. But if I wanted to, let's say I wanted to make compare, do a equals here. What will happen here? If I do a equals, E1 dot equals E1 dot equals E2. Of course, that is also going to be false. How it is false? If you see employee class, I never had a equals method. I just had a constructor. I have getter setter method. I never had a equals method, which means employee is extending from object class. So it is going to use the equals method of the object class. So what is the equals method of object class says? It basically compares the references, which means it is going to say E1 equal to E2. That's what it is going to do. So if you wanted to compare two employees and wanted to see their equality, even if you put the same values here, if you make it as E1, all these values same, all of these values are same, doesn't mean that these two employees are equal. If you say E1 dot equals E2, it is not going to compare the contents because it's something Java does not know basically how to compare these two employees. It's going to give you false only. Because you didn't override the equals method, you are using the objects equals method only. You have to tell Java how to compare your employee objects. What is the way to tell Java is, in your employee class you have to specify equals method and say like you have to override the equals method of the object class and you have to provide your implementation just like how string has done. So what you will do here is you go ahead and go to source and then say generate equals sorry, generate hash code and equals method. So it comes together, hash code and equals. We'll learn about hash code in a while when we learn about collections, but just focus on equals method. So here, in order to compare two employees, I don't mind if their address is different or name is different, but in order to say that two employees are different, their ID should be different. So I don't worry about their name or address. For example, employee can change his name or employee can change his address, but the ID will not be changing. So in order to identify whether these two employees are equal, their contents are equal, they refer to the same employee or not, I will be, let's say today he's coming from Texas, tomorrow he is coming from a different state or whatever. He can change his state or he can change his city. So it doesn't matter, like if he changes address, still he is the same employee. So if he changes his name, still he is the same employee basically. But the ID would not be changing. So I would like to compare two employees only by ID. So I can select this field alone and then say generate. You see the equals method is automatically generated by Eclipse and given to you. Also one more method called hash code. Don't worry about this now. Let's focus on this equals method. So this equals method, what it is doing is basically it's comparing the current object is equal to, if they are referentially equal, if they refer to both E1, if the reference itself is equal, then the value will be equal. There is no doubt about that. If they both are referring to the same location, then it's referring to the same object. So you don't need to do any comparison of ID or name or anything like that. You don't need to compare the fields itself because they point to the same object in the memory itself. So if they are equal, you're going to return true. If the first object is null, the past object is null, you're going to return false because you are comparing against a null, which is going to be always getting false. And this check is to ensure that you are not comparing an employee with a manager or employee with Apple. So the class that you have currently should be equal to the passed objects class actually. So that's what comparing here. Once these checks are done, if we are having the same class, they are not referentially equal. If all these things are not, if all these things are, came through, you will be converting the object into employee. You will be casting the object into employee, because the equals method is an overridden method from object class, and they accept only object parameter, not employee parameter or anything like that. So employee itself is an object, so we can pass anything to this one. So now I'm converting the object into an employee type, because I pass only the employee type, of course. So I'm just casting that to employee type, and now I'm checking whether the ID is null. So if you see here, ID is a string or a hat, so I'm checking whether the current ID is null. If the current ID is null, then the object's ID is also, should also be null. The other employee's ID should also be null. If it is not null, then I'm returning false. Else, if both are, else if I'm checking whether this ID is equal to the other ID. If they are both equal, then I'm returning true. Otherwise, if they are not equal, I'm returning false. So this equals method says whether two employees are equal or not actually. So now in this scenario, now go ahead and test this one. Okay, I'm just changing, I have all the name and address are same. I'm just going to change only the employee ID. Now I'm invoking e1.equals e2. This is not now going to call the object equals method. It is going to call the employees equals method actually, because I'm comparing with the employee object actually. Since I have overridden, it is going to use the overridden method. So go ahead, run this. So it's giving false because 100, 101, they two are different employees actually. That's what it's giving. They are not equal. But if you have it as 100, let's say, and you want to change the state, change the address to CT, that's fine. As long as my ID is equal, it is going to say that they are the same employee. Even if you change the name, it is going to give the same results. It's going to get it as true. So this is the way the equals method work. And in StringBuilder and StringBuffer, this equals method has not been overridden by Java. That is the reason it is using the object class equals method. Okay, but whenever we write our objects, we should be making sure that we define how to basically compare our objects. If we don't do that, then it is going to use the object class comparison method, which means your objects will never be equal. Okay. The next thing is on the toString method. Let me talk about that as well. So if I am printing, let's say I created the employee object. Now I want to print the employee object. So I want to put e1 here. I want to print this employee object like this. So what will happen when I put e1? What's happening here is when you print any object, person object, employee object, string buffer object, any object, automatically it is going to append toString to it. If you print any object, it is going to add toString to it actually. And this toString, where it is implemented is, it is implemented in object class actually. So if you go through this open implementation, it's going to be in the object.class. And you see a toString method which is returning a string, which is printing the class name at and then a number. You see here, this is the class name of employee, and then you have a at symbol, and then there is some hexadecimal characters coming out here. So what is happening here is when you call e1.toString, toString method is not present in the employee object, so it is going to the parent object, which is the object class, and it is printing the toString. It is going to execute the toString method there and prints this content actually. If at all you override this toString method, then it will not go to the object class, it will be using your employee class toString method. So that's how you have to do. So go to source and then say generate toString, and you want to select the fields that you should include in the toString method. I want all the fields, so I'm saying generate. So you see here, public string toString, it is going to return this employee ID and the actual ID of the employee, actual name of the employee, and then actual address of the employee. So I'm printing all the fields out here. Now if anyone tries to print e1.toString, or even if he just gives e1 itself, because automatically e1 when you put, it's going to call the toString method. It's going to convert into e1.toString. So if you see here, it's going to print the actual employee information here. So this is the purpose of the toString method. We were using the toString method in our StringBuilder demo to convert our StringBuilder object into a string actually, which is a string representation of the StringBuilder object. Right. And As such, for the string builder or string buffer, you have the demo, or like we have various methods like which we can use. We have like sb1 dot. Mostly the important method we use is append method. We can append any values to it. So you don't need to specify sb1 equal to here. If you specify it also, it's not going to impact anything. So see here. Oh, I did not print it, so let me print it. Sorry. Okay, so you see SB1 is having SB1 ABC XYZ. You don't need to put SB1 equal to here in case of string buffer, because it's going to update, it's mutable one, it's going to update in the same location. You can use many other methods. You can use a SB1 dot reverse method, which is going to reverse that. You can use replace method, reverse method, a lot of methods are there. You can try it out on your own. But here my what I wanted to importantly highlight is the mutability of this thing, and so you see it's getting reversing the string. The main thing is the append method, which we use mostly to append a lot of things, a lot of strings, and also doing some operations. Mostly we will not use the delete and insert, but most of this, but you have a lot of functions there. You have a lot of appends, which is adding an integer, character, all these things. You have the same functions like string, like character add, and then delete. Delete is just going to use to delete from a given start and end positions. And we have index of, which we already covered in string. It's the same thing here. Insert, again, we can insert into a particular, if you have a ABC and if you want to insert, let's say sb1 dot insert, I want to insert in 0th position, I want to insert say 1 2 3. So what will happen is, this will add ABC XYZ, but it's going to add 1 2 3 before the ABC, so it's going to say like okay, I did reversed it, so it added 1 2 3. It was having 1 2 3 ABC XYZ. Now it is in the printing in a reversed format because I reversed it here. Let me comment out and then just do it again. Now it is printing 1 2 3 because it's inserted in the 0th position. You can insert, if you insert it in the first position, is going to have like A alone will be there and followed by 1 2 3 here because it's inserted in the first position. Similarly, you can use delete and other operations.